this exercise will propose a state model for a car. So the car is represented on this figure. The actuators for the acceleration are applied only on the front wheels. We'll assume that the speed of the left and right front wheel are the same. So it is the same as if I have only one wheel in the center, and this is why the model we will propose is sometimes called a bicycle model or also a tricycle. So it is represented on the right. The point A corresponds to the center of the front axle, and M the center of the rear axle here. Theta corresponds to the heading of the car, and delta corresponds to the angle, the steering angle of the front wheel. So for this, about the state we consider corresponds to the degrees of freedom. So the degrees of freedom x and y is the center of the car. I will have also delta and theta. So I have 4 degrees of freedom. And the kinematic coordinate is only v. So it means that if I know v and if I know the degrees of freedom, I can compute all other speed of other elements of the car. So to find a state model, I consider here the car, and the state vector x corresponds to, so the degrees of freedom it will be x, y, theta. So it is, I will have the speed v here and delta. So what I want to obtain is something like x dot equal f of x and u, and the input u1 correspond to the acceleration, and u2 is about the steering, to change the direction. That's why I should obtain something like x dot equal, so since so take care of the difference between x the state and x here, which are different. So x dot here, x is the state, here is the state, but here I will obtain something like y dot, theta dot, v dot, delta dot. So all these one correspond to x dot, and here I should obtain something which is f of x and u. So it means, so x the vector here, vector. So it means that here I am only allowed to have x, y, so this x, y, theta, v and delta, u1, u2. Okay. So from the picture first, if m m correspond to this point, so here is a point m, first I can understand that I will have x dot equal vm cos theta, here vm sine theta, but we should understand that Vm is not allowed since it is not a state variable. Only state variable and inputs are allowed. So how can I obtain the right formulas? I will have to consider the speed composition rule, or the formula of Varinian, which tells me that since the distance of A and M is the same, I can say that the speed of A, VA, equal the speed of M plus the vector AM vector product with omega. So omega, it will be in this configuration, if since my car is now turning in this way, I will have omega, which is like this. So in the 3 dimension. So omega is called the instantaneous rotation vector of the car. So if I apply this formula, but I will express it in the frame of the car. So the frame of the car is like this, and I will represent this formula in this frame. So I will obtain for the speed for point A, I will obtain here the cos and sine. So I will have v cos delta, v sine delta, and here 0 since I have no components on the third direction. I have a planar model. Now here m always goes, so the vector speed corresponding to m is like this. Okay, so I have only a component with respect to the x direction in the frame of the car. This is why here I have Vm 0, 0. So I have no component with respect to this direction. So plus, now I will have for Am, so Am is like this, so if you prefer like this. So there is a component with respect to the x direction, and since this distance is L, I will have here minus L 0, 0. Okay, 0 because I have no component with respect to the y direction in the frame of the car. So vector, now in the frame of the car, here I have 0, 0 since omega has only a component with respect to the third dimension. Theta dot. This means that, so I will only take care about the two first components of this vector equation, and I will obtain v cos delta, v sine delta, here and here, equal Vm plus 0, because this time this and this time this equal to 0. Okay, and here I will have for the second component this time this minus, so I will have here L theta dot. Okay, due to this cross product. Okay, so from these two relations I obtain that theta dot it equal v sine delta divided by L, and this is why here I put v sine delta divided by L. Now I will have Vm, which is here, equal to v cos delta. This is why here I will have v cos delta cos theta, and here v cos delta sine theta. And since I control the acceleration, so v dot by u1 and u2, so what I have here in blue corresponds to the state equation of my tricycle, since I have the derivative of the state variable that are given with respect to the state variable themselves, but also to the two inputs.